that the okay. All right. Okay. Ahmad, and whenever you're ready.
Sure. Yeah, I hope now my slides are
Yeah, looks good.
okay.
Looks good.
Hi everyone. My name is Ahmed Chokhatian. I'm the PhD student of Professor Yuding's team in Georgia Tech. Today I will talk about the main challenge of the space, quantifying the turbine upgrade, and I'll just go through a quick recap of wind-up and compare P curve methods. And we'll also introduce a new approach, which is a combination of these two methods, and we'll see the numerical performance of different methods. So wind-up was presented by Mr. Alex Clark on September 16, and the slides and recording is available in the WeDoWind platform. I will have a brief, actually, a review of this method, but in case you are interested in more details, please feel free to check out the slides and the video of the talk on platform. So the windup was actually generating a corrected wind speed using the inverse power curve of reference turbine, but for regions near zero and rated power, as the power production is constant, is flat for a range of speeds, the nanometer speed was used. Then Windup also plotted the CP and directional detrending plots, and they helped the tool to filter out some ranges of the wind directions, and that way the weight data, the data under weight condition would be hesitated to be used. And then finally, for quantification of the improvement rate, the method used blocked bootstrapping and the reverse analysis to check the robustness of the results. Finally, it came with a point estimator for improvement rate and also the uncertainty of the estimate. The implementation and configuration of the windup for the specific data in our space, vortex generator and pitch angle, is shared in a GitHub page, which I also provided the link, so you may just click and take a look at the code. Then on the other approach we discussed in a series of the talks for WeDoWind, initially discussed by Professor Yuding on Feb 5, was compare P-curve, and then I reviewed the method and discussed how to implement it in R using the DSWE package in November 11 meeting. So this method is for a discussion about the method. You may check out the Feb 5 slides and recording, and for implementation, the November 11th. So compare P-curve had several steps. Compare P-curve first started with matching the pre and post upgrade data with hierarchical covariate matching. The aim was to just keep the data with a close distribution and the environmental features. And then fitting the method fits one Gaussian process model on each one of the pre-upgrade and post-upgrade data, and using these Gaussian process models made predictions on the same grid for both data, and then taking the difference of these predictions. So the difference would be the orange region in the left plot. But the fact is that some of these differences at some regions might not be statistically significant. Then the method also does a statistical test and just keeps the regions where the difference is significant, like the blue region in the bright plot. So the statistical difference is smaller than the difference, but is more reliable to claim for the improvement rate. So the combined approach actually is designed to use the windup for preparing the data because windup's unique approach for pre-processing, actually just filtering out some ranges of the direction and so on, might be one of the main reasons that windup is achieving good results. On the other hand, compare p-curve offers a standard and a pretty good method for measuring the difference of the power rate improvement rate. So what we thought is combining these methods by using the windup for preparation, preparing the data, and then compare p-curve for measuring the statistical difference. So the process is straightforward. We just use both data sets for we implement it on both data sets. For example, we feed the pitch angle data to windup, and then just before start of block bootstrapping, when whole pre-processing is done on the data, we take the prepared data and take the two columns of corrected speed and normalized power, and use the compare p-curve to calculate the statistical difference. So results for these methods and other methods in the literature are summarized in two tables. R is nominal power rate. So pitch angle was a simulation study. We just created different data for different nominal power improvements rates, and then also calculated the effective power rate, because really the effective power rate is when the difference between the power rate is on the whole region of the post upgrade data. And the above table shows the estimates for each method, which we claim a method is good when its estimate is closer to the effective power rate, R prime. But to really easily interpret this table, we just also provided the table in the bottom, which all these estimates are divided by R prime. So when we divide the estimate by R prime, the method is good when the estimate is closer to the 1. For example, for R equal to 2%, where effective improvement is 1.20%, the combined approach really achieves 1.25%. When we divide them, it's 1. So really, this combined approach performs the best over all methods. This conclusion that the combined approach performs the best keeps for 2, 3, and 4% improvement rates, and for larger improvements, the combined approach underestimates. And compare p-curve is the winner overall over those higher rates. Also, Shin's method, Shin 2018 method, has its own merits, and for 5 and 7%, it's achieving the best estimate. The other observation is that windup alone is always underestimating. Also, the combined method is underestimating, but combined methods seems to improve the windup. On the other hand, as I said, also Shin's method for some rates is the achieving the best. Next, we also calculated the improvement rates for the VG data. For this data, we really don't know the ground truth, we don't have the R prime, so we can just see what methods estimate, but we cannot claim any of them is doing better than the other. So for different methods, we really get a range of values from 0.87 to 1.74 wind up, and all these methods, it seems that combined approach has the smallest, wind up has the largest, and the other three methods are somewhere between. To conclude, we introduced a combined approach using the windup for preparing data and using the compare P curve for measuring, quantifying the difference between pre and post data set, which underestimated combined approach is underestimating the power improvement rate for higher rates and constantly improves windup. Combined approach, however, is better than compare P curve for lower improvement rates, but for higher improvement rates, really the compare P curve does perform better. For VG data, we didn't really have a clue on what is the ground truth, but different methods get a wide range of the improvements. And to claim a less robust number or effect for the VG, we may really just take the average of the estimates from all methods. That's all for today. Thank you so much for your attention. Any questions?
Okay, thank you, Hamad. Can you go back to the, well, can you maintain in the
Sure.
presentation mode?
I'm sorry. Yes. Which
Can
is
you go back to slide number 7?
yeah, here.
Okay, so here I just like explain since we actually said this in when we release the data, the R percentage here is applied to a subset of the wind speed. I mean the wind power corresponding to the subset of wind speed, and therefore if you mix all the wind speed and their power together, the improvement is not really a 2% uniformly, and so we calculate the effective, which is R prime, and like Ahmad mentioned, if the estimated improvement over the R prime ratio is 1, that means that you perfectly recover or estimate that the R prime value. If it's less than 1 or over than 1, you either underestimate or overestimate by a certain percentage point, right? 0.9 meaning you underestimate 10%, 1.1 meaning you overestimate 10%. And the more deviation from 1, it means a bigger misestimation value. So that is basically how to read these two tables. The upper table is the actual estimate. The lower table is the ratio compared to R prime. So any comments, any suggestions? We don't really have, yeah, Alex, please. We don't have a perfect method yet, but I think we, there's some improvement progress. Yes, Alex, please.
Thanks very much for a nice presentation, and yeah, thanks for giving the wind-up tool a try. It'd be nice to collaborate on this. I guess so. Yeah, that was my main question. I think you just addressed it, Professor Ding, was about R prime, which is the ground truth in this table. Like I guess I have a lot of questions about how it's calculated. One of the key decisions when reporting an uplift is whether you're reporting it based on the wind distribution during the upgrade, or you're trying to do a long-term distribution. Windup can do either, depending on how it's configured. So I guess that's a reaction as well. My first suspicion is perhaps there's some wind distribution mismatch in these various columns that might explain some of the differences, perhaps.
Right. So this is the simulated data. So for the data you have, we have the one before simulation, which is really the baseline, and then you handle the power after simulation. You simply just add them together and divide it, you get the percentage, right? If you put a 0 over there, the percentage should be 0 because nothing really changed before and after the change. Because for many of the turbine, the actual physical upgrade or retrofit, we don't really know the underlying truth. This is the difficulty with the VG things, right? You don't really know exactly unless you do a kind of wind tunnel experiment, but which is not really doable for the actual size of the turbine. And that's why we created this simulated data. Now, of course, the simulation of the data is also up to debate. We can discuss to say what is the best way to simulate the data. And for here, there's not really much extrapolation. It's really, you have, you just try to, I mean, any method being applied, we just try to say how much you recover from that period and which you have made the change. I mean, multiply that R ratio, right? R number. I believe the wind up, Ahmad, we take directly from Alex's presentation from September 16th. Is that right?
Then the numerical results.
Uh-huh.
No, there is just one change. So all these methods are applied to the control turbine, applied to the test turbine, and then the numbers are reported in these slides is test minus control. So that was because we wanted to, already the other numbers and other methods was calculated this way. So I also did this for wind up. What if I just do the just try to replicate Mr. Clark's work on wind up, then the numbers matches with his slide. So
okay. So what is presented last September, the number is different from the column you showed on this slide?
yes.
Because
yeah, a little bit different. Yeah, not. But what you're saying makes sense. I understand why it's different.
For example, for VG, I think the number on September 16 was 2.3. Now I reported 1.7. That's because when I applied it on control turbine, it was 0.6. So we did 2.3 minus 0.6.
Okay, that's but we do replicate the result for the test turbine to match what is being reported previously. Okay, that's good. I do still see, the need for further improvement, right? Because right now there's no one method uniformly kind of just get all the result correct. They either do well on one of the spectrum, the low end or the high end, but once they move to the other end, it looks like they have either overestimate or underestimate issues, which we still want to figure out. Like Alex, like you mentioned, I'm very interested in, collaborating, even I'm not really sure we have enough result to present in April. That's why I said we may not necessarily have another presentation anytime soon, but we could, discuss with each other to see if we can, have even enhanced version of this two method or some other new method.
Yeah, I'd definitely be interested in looking at your code if that's, I don't know if your code is public or not, or but yeah, if it is, I'd be interested in having a look at your, I think you said hierarchical covariant matching you used, or
yeah, it's not public, but I can just put some comments, kind of make it neat and then share with you if you want to take it.
Yeah, nice. And I'll mention I'm preparing a data set to open source. It should be in a month or two, which is another onshore wind farm. It has a few real upgrades. It's going to be 8 years of data, 21 turbines, kind of modest sized turbines, like 80-meter diameter, 2 megawatts, something like that. And we could use that to do further studies, because there's definitely a lot of noise in studies like this. So when you can study many turbines instead of just a few, it certainly helps with issues like, oh, my reference turbine is showing a non-zero uplift, which it does happen. And so a larger volume of data is very helpful. So I'll be happy to share details. I see Sarah's on the call. Sarah's recommended I do another We2Win series on it, which I can probably do once the data
it'd be
set
great
released.
if you continue the effort, right? We can move to your new space and using the data you can possibly share. That'd be great. Just one comment to what Hamad mentioned. The compare P curve code technically is open, because it's part of the R package. All the R package code is open. It's just that you need to know how to extract the source code. If you don't, of course, you just call the function, right? But technically, all the, because it's called the open source platform. Everything is open. But like he said, we can actually share the code directly with you. That way, you don't have to kind of dig out the code. Yeah. And Sarah also dropped a comment in the chat box saying, be mindful of writing a collaborative papers. Different method can be compared and then identify potential improvement. I think that's a great point, and I think that's exactly the type of things I have in mind. Right? We even given the current result, we could possibly already write the paper, but if we can identify some further improvement and make a even better result, and that'll be great. Yeah. Any other comments from other audience and participants? Any suggestions? So Alex, when you have that additional data, if you think that can be made shared with the participant, I'd be happy to share through this workspace. But if you if you plan to open a new workspace on similar topic, I'm more than happy to join your workspace as well, and then continue the collaboration from that point onward.
Great. Yeah, happy to chat over email. Yeah, happy to work together more on this. I definitely would like to dig into, I guess I still see on the screen the statement, wind up generally underestimates the uplift. That's definitely not the intention. I hope that's not the case, but maybe it does, maybe it doesn't. I don't know. It would be good to, I guess, do some more comparative studies together, especially if everybody has access to the code and the data, then we should be able to eventually get to the same understanding. Your description of compare P curve sounds really cool. The hierarchical matching sounds like a really cool idea. So pretty interested to try it.
Right. So like I said, the very way to simulate the data is also open to discuss, right? I'm not really saying, we just use a very simple way to do that. And in some of the previous publications, nobody really kind of say this is not correct or something, but there are always kind of nuisance issues need to be corrected and to be perfect. Because if the underlying truth cannot be really well assessed, there's a certain kind of complexity now will capture, and whatever the comparison only can testify to that particular simplified setting, and which may not necessarily extend to the general real life setting. One of the things we observe actually quite surprised us is in Ahmad's analysis of the VG part, right? We find this in the simulation data, the wind up and the combined approach always tend to underestimate, right? But here, the wind up and the combined approach on the two very different spectrum. One is the smallest, one is the largest. And that is really, we don't really expect to see this result, but when we report that nevertheless, because we believe, even we don't understand, we need to let in the open, right? Because other people could come up with a better idea or better method to correct this, for the time being. And I believe the best approach is simply just the average all the estimate together, which in the end gives some estimate closer to the compared P curve alone. It's about 1.3. On this particular data, because the data was provided roughly about 10 years ago by EDP North American unit, and they do believe, you know, the improvement. How do they come to that belief? I don't really know, but they do believe the improvement is between like 1 to 1.5%, and they have some strong reason to believe in that sense. Yeah. Okay. Anything else? And other comments? Okay, if that's the case, it looks like we can finish today's meeting in about half of the allocated time, in 30 minutes. And Alex, I will follow up with you afterwards and to dig into a little bit further into this things. And I'm very delighted there's really someone we can work with. That's exactly the point of this collaboration workspace. If anyone else are interested in the effort, you know, drop me a note, and you know, we can obviously work all together. Okay, all right. Thank you very much, and I will wait for a few more, maybe like a week or two, and to see if anyone come up with some things want to present for April or May. And if I don't hear anything from you all, and I will probably just cancel our 2 meetings. And then if we have something new come out, you know, we'll schedule another time and maybe make 1 more or 2 more presentations. Okay. Okay. We'll see you around in some professional occasions afterwards.
Thank you. Have a good day.
Thank you very much.
Thank you.
Thank you. Bye.